Hello everyone, welcome to Analytical Chemistry, and my name is Jumel W. Fernandez from B-Sci-Ed 3B, where I'm going to discuss about the Volhard Method. So first, let us define what is Volhard Method. So Volhard Method is an indirect or back titration method used to determine the concentrations of chlorine, bromine, and or iodine ion in a solution using known solution silver nitrate. The titrant is a standardized thiocyanate with ferric ion as an indicator, and it was first described by the German chemist Jacob Volhard in 1874. So there are three steps in Volhard method in order to determine the amount or concentrations of um, chlorine or bromine or iodine or the the halides that we are going to determine. So the first step is analyte is treated with measure exist of silver nitrate, and the second step is the unreacted silver ions are titrated with the standard thiocyanate ion using ferric ion as indicator, and the third step is the first slight exist thiocyanate ion give red color of ferric thiocyanate. So the first step is when in order to get the exist of silver nitrate, we have to mix the two solution, and so that we can have this so like this X is the analyte and this is the silver ion. So in order to get the exist of this silver ion, the known solution, we have to react this with the analyte. So in order to get this silver ion exist, so what are we going to do with the silver night ion exist is we have to titrate with a standard thiocyanate ion. So there are two types of standard thiocyanate ion. We can use the ammonium ammonium thiocyanate or um, the or the wait yeah we can use ammonium thiocyanate. We can use ammonium thiocyanate in order to react with the unreacted silver ion. And the third step is so when the the silver ion and the exist silver ion and standard thiocyanate reacted, there is still exist of standard thiocyanate. Then the the exist standard thiocyanate will react with the with 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 ferric ion that gives red color of ferric thiocyanate. So in order for us to understand this method, I have an example here where we're going to determine the amount of chlorine in sodium chloride. So the first step is we're going to mix this sodium chloride and the silver nitrate solution in order to get the exist silver nitrate that we're going to use in the second step. So how does it happen? So when we mix these two solution, the sodium chloride chloride solution and silver nitrate solution, it will give us it will form um, silver chloride and this. So, however, when these two solutions reacted, there are still exist silver nitrate that that we're going to use in order to determine the amount of chlorine in the solutions of sodium chloride. So the second step is the exist silver nitrate is titrated against with ammonium thiocyanate. So when this when the exist silver nitrate reacted with the ammonium thiocyanate or the standard thiocyanate, it will give us silver thiocyanate and this. Then, however, when even though that these solutions reacted, there are still um, exist of standard thiocyanate. So we can proceed to the step 3. So the step 3 is the exist thiocyanate will react with the ferric ion and it can form red colored or what we call the ferric thiocyanate. So when the indicator isomini this ferric ion is indicator indicator and when the indicator will react with thiocyanate and change its color in color, this means that it is called the end point, and this means that in this point where the analyte has completely reacted with the titrant. So this is the last step that we're going that that's really important to know as when we use Volhard method, because when the ferric thiocyanate react, it gives color red, that it means that the chemical reactions is already done, that we can now able to determine the concentrations of chlorine in the sodium chloride solution. So how so we can determine by subtracting the titration of the moles of silver ion that reacted with the thiocyanate from the total moles of silver nitrate added to the solution. So yeah, so the end point is so yeah, we can now determine the amount of concentrations of chloride when the ferric ion already reacted with the standard thiocyanate. It gives red color, right? So that means that the chemical reactions or the analyte has completely reacted with the titrant. So we can now determine the amount of concentrations or concentrations of chlorine in the solutions of sodium chloride solution by subtracting the concentration by finding the moles of silver ions that reacted with thiocyanate from the total moles of silver nitrate added to the solution. So take note that in using Volhard method, titration must perform in acidic medium to prevent the precipitation of ferric ion as hydrated oxide. The indicator in concentration should not be more than 0.2 m. If the silver with analyte precipitate is less soluble than um, silver thiocyanate, they do not need to remove before titrating with standard thiocyanate, such as a case of iodine and bromine. So the application of Volhard method is this can be used for the determinations of halides. Like I said earlier that it can use in finding the amount or the concentrations of halides like chlorine, bromine, and iodine. Anions like phosphate, arsenate, chromate, sulfide, carbonate, and oxalate. Potassium as potassium tetraphenyl borate and fluoride as lead chlorofluoride. So the advantages of using this method or the Volhard method is useful where the titrations have B as titration is performed at low pH, and the strong acidic environment gives advantages for halides analysis because ions like carbonate, oxalate, and arsenate do not interfere. And lastly, it gives accurate result due to back titrations. Also, aside that there's advantages, there's also limitations of Volhard method. So the first is cannot be used where the solution has to neutral, and it also time consuming because in using Volhard method we have to use different laboratory apparatus, materials, and tools that we need to set up in order to perform the Volhard method. Like for example, in mixing the when mixing the two solutions, which is the sodium chloride and the silver nitrate, in order to get the exist silver nitrate, and when titrating, and yeah, then the last is sometimes we give false endpoint. So that's it. Thank you so much for listening, guys, and I hope that you learned something about the Volhard method. Thank you.